Hello everyone, I want to talk to you about the Lecture 7 parameters module that we have up. So in this lecture we talk about a few different topics. We have default arguments, we have passing by value, passing by reference, static variables, function overloading, a few library functions just listed out. So I want to talk to you real quick about some of this in a video lecture. That way we can kind of see it hands-on a little bit. Some of you guys may prefer the video lectures to the written content. So I want to go ahead and just give you an opportunity to kind of grasp it in a little bit different of an explanation here. So starting off with the first portion here, default arguments. So with a default argument, that basically is a way for a function to have an initial value, a default value, so that if a value is not provided, an argument is not sent in, that it has something to grab from automatically. I'm going to go ahead and start off a basic program here. Make this a little bigger so you guys can see it. Okay, so if we had a program, we're going to call this program void print name. I'm going to call this void print name. And in this function here, I'm going to take a string. I'll put a random semicolon in there. And I'm going to go ahead and include string so that I can use it, and I already have my standard namespace here, so this should be fine. And I'm going to ask for a name and then print it out. So cout, what is your name? And I'm going to print that out. Actually, what I'm going to do is I'm going to ask this in main. Then I'm going to cin name, which means that I'm going to have to, whoa, keyboard, string name. And once I declare name and then I ask for name, I'm going to print this name out. I'm going to say hi, and then the name, and then we'll say exclamation point at the end. Why not? All right, so very basic function. All it's doing is just saying hi, name, and then that's it. So what if we never provide a name? So like, what if we don't get a value for name and we call the function? So that function will have an initial value right off. And I use this kind of abstract model just to start, so we can kind of see how this lines up with the lecture that's up there. And then what I'm going to do is I'm going to kind of show you how this would actually be applied. So you may notice that I'm missing my function prototype up here. I need to prototype this function in order to be able to use it. The function prototype just says, hey, look out. This is something that's going to be declared later on, so that it understands what is upcoming. And the reason for this here is that inside of main, because this function is below main, if I were to call this function, like right here, if I were to call this function print name, and I were to send it name as an argument, I'm going to go ahead and comment this prototype out real quick. This would freak out on me. I don't have IntelliSense working on this project here, but trust me, this would be an error here because there is no prototype on this function that's down here. So because there's no prototype, it has no idea what this means because there's no previous declaration of it. It's not defined until down here. So in order for this to work, we need to either do one of two things. We need to make sure that this function is defined above main, or we just simply put a prototype. I like using prototypes because I like having main up front and center. It's nice. It's very easily read when you can just kind of scroll down here and, oh, there's main. Later on, your programs are going to get bigger. You're going to have hundreds of these things running around, these functions maybe. So it's nice to have your core pieces right up front, so that way we can just skip to that and see what's actually being called in what order. All right, so print name is called here. We pass it name, and then there it goes. Now, in the event that we do not provide it a name, if we were to just not give it a name, this would also throw an error because, again, the reason why it's not throwing an error on mine is because I don't have the project linked, and there's just some issues with that. So the reason why I don't have my red squiggly line, don't worry about that, but this is an error because I must provide an argument. Why must I provide an argument? Is because I'm expecting one. My function is declared with a void return, so it's expecting to not return any data. See, there's no return statement here. And it is expecting to receive this variable. So when it doesn't, it freaks out, can't do that. But if I were to give this a default value, I could do this up in my prototype. This has to be done up in the prototype. And again, why you would do this in a why you would want to declare this below main, you need a prototype in order to be able to do this. So setting this to a default, we could say this is John Doe. And so by default, this would be called John Doe. So now in the event that this did not line up, I don't know if this would actually run. Yeah, I don't think it's gonna run. Let me see if I can let me link this project back up real quick. Okay, so this should do it. All right, so I have now the what is your name prompt, and we'll go ahead and put Tim. Now notice I'm not actually passing name into print name, so I should see John Doe. There it is. Now the reason why I see John Doe is because I don't send this piece of data into this function, and so since it gets no data from the call, it defaults to the default argument that is listed in the the header up here. So I'm going to go ahead and add name back in so that I'm passing that data back in. Now in the event that I do give it data, and I do have something populated in that data, it will override the default argument. So if it is getting data, it will use the data that's passed in. If there is no data that's passed in, then it's just going to be whatever default argument is there. So if we were to write a little more useful program, in the textbook, I believe they use an area calculator. And the area calculator is using as a default argument, I think, 1 unit or something like that. So that's kind of an area where, hey, a default argument works perfectly fine. If you were maybe making a character save data or something like that, you could maybe elect for a default argument. So say like if there was no previous data, if the user never played the game before, then they start off at a default argument of level 1. So there's all kinds of ways that you can utilize a default argument for your purposes there. So that's cool. The second thing that we want to quickly go over is that you can call a function inside of the call of another function. So what does that mean? Well, say if I were to make one more name or one more function here in this, and say if I had string, because I'm going to be expecting a type string return. What if I had string get name? So if I had string get name, and then I would be returning name. I'm going to use a variable called name, so that's where I'm going with this. So I would make string name, and then I would have a cn name, and then I'm going to take basically all of this functionality here, and I'm going to move it down here. It lines up the same. All right, so we create the variable, we populate the variable, and then we return the variable. So I can now get rid of this. And how do I get name now? Well, I can actually use my function get name. Let me go ahead and prototype it before I forget, because you know how I am. There's one thing I'm going to always forget. It's prototyping the functions, because I want to get to jammering on here. All right, so in order to print the name, we need to get the name. Well, whenever we get the name here, it's going to be returning this here. And a function call, when it returns data, turns into that value. So when it comes back, it's going to turn into the value that needs to be sent to the other function. So that's cool. So we're going to do get name, open and close parentheses. There's no data that needs to be passed into here. Again, it's not expecting any argument. And so this is going to turn into the name. And then that, in the order that this is going to go in, is it's going to go, okay, we're calling print name, but oh look, we need to go to this one here. So we go into print name, and then we go, oh, we need to go here first. And so we go all the way through this function and then go into this function. So it goes always in the inner functions first. And you can even go like even further. I mean, you can call a function within a function within a function. I mean, it gets a little ridiculous after a point, but we're just proving what you can do here. So you can call get name here. Get name's going to go get the name, bring it back, turn into this value here that then is going to be sent into print name, and then it's going to appear. So if we were going to go ahead and load this up here, what is your name? Tim. And then hi Tim. And that's because it's going, getting the name, returning the name. That is now the argument of print name. Tim comes here, prints out. That's it. So that kind of covers the, did you know you can call a function what's inside of another function as an argument parameter, and that whole bit is very well explained once you do that. All right, passing by value. So passing by value, I have a little section here that's talking about some default parameters and all this, this stuff that we've been talking a little bit about before, but it's talking about passing a copy of the value and all this sort of bit. So what's actually going on here? Here's the too long didn't read. If you are sending the data and you are creating a new variable to catch that data, you're sending a copy of this data. You're not actually sending the memory address of this name into this function here. You're actually sending another copy. So these are two different memory addresses. Even though they're called the same thing, they're in two separate functions. They're two pieces of data, two independent pieces of data. Now to prove this here, what I'm going to do is I'm going to go ahead and just kind of erase everything that I got here. And I'll just nuke this whole thing real quick. We'll start over. Let's just make a real quick, easy to follow example. I'm going to just say void function 1. Okay, and I'm going to put int number. I'll set that equal to 1. Then inside of function 1, I'm going to make int number, and I'm going to set this equal to 2. Now, what I'm going to do purposely here is I'm going to pass this number into this function. So I'm actually going to take this and move this up here. Let me just get rid of this here. We don't need this. So this number here, I'm going to go ahead and pass this into function 1. Number. All right, and I'm going to go ahead and prototype this function. Done writing it. There's nothing else that I need to write. So here's what's going to happen. I'm going to cout the memory address of number. Now, how do I output the memory address of number? Well, what I'm going to need to do is I'm going to need to use the ampersand, just one. Remember, two of these is the and symbol. One of these here is going to be, I'm going to have you call it the address of. Okay, so I'm going to use the address of, and that's going to print out the memory address that this lives at. Then what I'm going to do is I'm going to come into here, and I'm going to print out the same thing, and since it's called the same, I can just copy this here and move this down here. All right, so it's going to print out the memory address here and here. Now, if what I said was true, that this is a different memory address and this is a different memory address, here's what I'm going to do. I'm going to say memory address of number inside function. Okay, and then I'm going to pop this here. All right, so so by doing this, I'm printing out the memory address outside or inside of main, and then outside of main inside of this function here. So that way we're going to see two different memory addresses. I'm also going to print out their values. We'll just get all the data lined up. That way we can see everything underneath the hood. Of number is, sorry, I have this huge microphone in front of me and it's blocking. I have to reach around it to get to my keyboard. Struggle is real over here. All right. So this number is, I'm going to put number. So we're going to see 1 on this. And then we're going to see over here the value of it over here. And we're going to go ahead and I'm going to do this as well. I'm going to do number equals 5. And then what I'm going to do is I'm going to come back after we call the function. I'm going to ask one more time, what is the value? Now this will prove, beyond a shadow of a doubt, that there is two memory addresses created for these two variables. Okay, so here's what we're going to do is I'm going to run this here. Move this over here, and it's a little hard to see here maybe. Zoom in. The value of number is 1. Now that's inside of main. That's this statement right here. Memory address of number inside of main, and we see 007FF86C. That's this statement right here. Then we see the value of number is 5. Now that's not this statement here. Remember, the function is called. So the value of number is 5. And you see, because we changed the value of number to 5. Now we sent this number, which had the value of 1, into this variable here and then changed it to 5. Okay? Now the value of number is 5. That's where we're at right here. Then the memory address of the number inside the function is 007FF798. Now notice that these two memory addresses are separate. They're different. They're two different memory addresses. Then we return out of this function right back to the end of this line, and then we run the next line. Cout, the value of number is, oh look, we're back to 1. So if we pass data into a function via copying it, but so passing by value. So if we're passing by value, we're passing a copy of that into this here. We don't actually pass that original. Okay, so it's a copy. We do a bunch of stuff to it, and then when this function closes and dies, you just crumble it up, and then it's gone. It's just completely gone. And then we continue right off where we left off. All right, so the number that is here and the number that is here, these are two different instances of two different variables. They just happen to be called the same. So when we pass this in here, normally via this method, we're passing by value. All right, so now I'm going to change it up a little bit. I'm going to pass by something called reference. So when we pass by reference, what we're actually doing is we're not passing the value. We're not passing the value into the function. We're actually passing the memory address. So we pass the memory address. This is, hey, this is the location of where you can find the data that you're looking for. So when we pass by reference, we're binding this instance here to this. So that's why there's this little chain that's here. Is we're binding the reference together. So passing by reference, we're going to send the coordinates of how to find this thing, this number, okay? So here's what I'm going to do. We have number declared here. I'm going to pass the address. So pass the address of number. Do I do it like that? No, I don't. What I do is I come down here, and then I'm going to pass the value of this by number. If you look this up on Google, you might see some people doing this and all that. They're doing something completely different. Don't fall for all that, all right? So when we pass by reference, down in the function header here, we put an ampersand in front of this, meaning that we are looking for the address of whatever is being sent in. Now make sure that your function prototype reflects the same. Okay, you see that error clear there. Okay, so here's what we're going to do now. I'm going to go ahead and I'm going to run this program. We're going to see some weird stuff. The value of number is 1. That's the statement right here. The value or the memory address of number inside of main 003EFAFC. The number or the value of number inside of this function here ends up being 5 because we changed it to 5 here. Now let's look at the memory address. Look at the memory address. It's the exact same. And the reason why it's the same is because this variable is now bound to this link here. So as long as this function will stay open, which it is, it's main, as long as this function stays open longer than this function, it will always have a direct reference to this variable here. Okay, so same memory address, and now look at this. The value of number is 5. That's back here in main. So that means here in main, the value here changed to 5. So the crazy thing about this is that we actually affected this variable back in main. We changed the value of this variable with this statement right here, because that change got saved to this location. So because it's bound to the original instance of wherever the memory address was when we grabbed it, and that's here, this line is changing and affecting this declaration. Crazy. And you know that that's true too because I made this function on purpose a void function. That means there's no way for data to get out of this function. So this is kind of like the hidden tunnel where you can get data back, is by linking reference to the memory address here. So that's what we've done. Static variables. All right, so static variables. We have the ability to keep persistent values going even after a function returns. So rather than typing this whole thing out, let me just quickly explain this here. Say we have this function here called enemy health. And every time we need to change the enemy health, we need to just give it an amount to damage itself by, okay? So in this function here, we pass damage, and damage then changes the enemy health from wherever it was down minus X amount of damage. Okay, and then it will just print that out. So the problem here is like if we did not have persistence, it would always start from 100 and go down. So say if we hit the enemy for 5, like we're doing here, then it would go down to 95. And then we call it again and we say hit him for an additional 5. This would still be 95. Why? Well, because it's creating a new variable, setting it equal to 100, and then minusing 5 off that, versus creating the variable, taking it at 100, and then remembering where that variable was and keeping this persistent so that it doesn't destroy it and then recreate it. It keeps it open. So the static keyword in this case here, by doing static data type int, static int enemy health, what this is going to do is it's going to keep this persistent for as long as the program is running. So in this case here, when we say, okay, minus 5 health, result's going to be 95. And then we say, okay, enemy health minus 5 again. The result's actually going to be 90 now. So it's going to be going down because it remembers where it was before. The reason being is because it doesn't destroy this variable. It keeps it alive. So that's what the static keyword is doing for the data types that you see declared here. So that's how that's working. Later on, we'll maybe get into, if we have some time, this is kind of more of a 17a topic, but we'll look into static persistence with functions as well. So you can do that as well. But it's probably going to wait until 17a. Last but not least, function overloading. This will be a topic that is on the midterm, so this is definitely something you want to understand in great detail. Now, the function overloading portion here, there's 2 ways to overload a function. What is function overloading? The too long didn't read of this topic is you can have a separate declaration for the same function that you write. So say for instance here we have add nums and you see 2 integers here. Well, what about if we wanted to add integers, but say we have one that's a fraction, so we have 1.5 plus 40, right? 4 plus 4.5. Well, if we were to do that, we would run into trouble because ints don't use precision. Floats and doubles do. So in this case here, we really need to, and that may spawn the thought to where it's like, well, why don't we just make the function just do doubles? Well, you can do that. You can do that. Another thing you can do is you can do function overloading. And function overloading allows you to use the same identifier for the function. You have to make it the same. But the argument parameter list will be different. And that's either different in length or different in the amount of arguments that are there, or the type of data that it's accepting. In this case here, it's a mismatch of different types of data. So we have one that it does ints and one that does doubles. Now notice the declarations are just slightly different. This one uses doubles, this one uses int. Same function. Now the compiler will be smart, and it will choose the one that matches its argument list. So in this case here, we have 2 numbers and they're 2 ints. It will automatically choose this one here that is lining up with the int argument list. This one here, obviously doubles. It will choose the double argument that's down here automatically. The other way that you can do this here is you can change the length of arguments that are in here. So in this case here, where we have add nums, we accept 2 arguments. We'll say if we wanted to accept 3 ints, we can make a overloaded version of add nums that will accept 3 integers. So that way, back home here in main, if we just threw 2 numbers at it, it's like, yeah, no problem. I can handle that because I have a definition for this. If we put in an extra number, yeah, no problem. I have a definition for that as well. And that's really functional overloading in a nutshell. The textbook does a really good job of defining this. I have a little snippet of it here, but it's a pretty basic concept that you can just quickly grab and run with. Library functions, I do have a link that's up here that has a little bit larger list of built-in functionality in the language that you can use. And you can refer to the textbook as well. The textbook has a whole page dedicated to just some extra stuff that's written into the language. So that is all of this parameters lecture here. I'm going to go ahead and stop it here. And please post to the discussion board if you guys have any questions about any of this here, or if I can elaborate a little further. Thanks, and good luck on the midterm.